পাইছো? হয় হয়। Okay. Okay. I think we can go live now. So welcome everyone to this interactive session of NPTEL. So this is the interactive session for this particular course called Mathematics for Economics Part 1, which is offered from the platform of NPTEL. And we have been running this course for last 3 months. And this course is going to conclude on this month itself. So the final exam will take place towards the end of this month. And from time to time, we have these interactive sessions with the students who have enrolled in this program to clarify their questions or queries. And before, we already had 2 interactive sessions over the course of this uh, particular course, Mathematics for Economics Part 1. So this is the last or the concluding interactive session. So those who are joining or planning to join, please ask your queries. We are right now live on YouTube channel also. And so if you have some questions or queries, you can type your questions or queries on the chat box on the YouTube channel. Or if you are joining through the Teams, then you can, verbally ask me the questions, live questions. So just to remind our viewers, what is the part of this course that we are planning to cover in this session. Obviously, we cannot cover the entire course in one particular interactive sessions. So in the last 2 sessions, we covered parts of the course and we took questions from those parts. In this last session, we are going to take questions from the last 6 weeks of this course, and which essentially basically covers single variable optimization, right? Those maximization and minimization exercises that we did, and we did a lot of problem solving also in our discussions. So if you have any questions or queries from that part, you can go ahead and ask. So apart from single variable optimization, we also covered in this last 6 weeks integration. Okay, the idea of integration and the application of integration in economics. Essentially, we use the idea of area of a curve under a curve. That is the idea of a definite integral. That notion we use in economics application as well. And we talked about some particular applications in economics, such as, the Lorentz curve, or the distribution of income, how in those contexts integration can be very useful. Or for example, the idea of Gini coefficient. This was the second, I think, main topic we covered in the last 6 weeks. The last topic we covered in the last 6 weeks was the difference equations. So in difference equations, we talked about different kinds of difference equations and what is meant by the particular integral or complementary function of our difference equation and how to solve them. Okay. And not only solving them mathematically, we also talked about the economic applications of difference equations, such as the cobweb model, right? Or the inventory model. Those were the things that we talked about when we talked about the applications of difference equations. So if you have any queries regarding difference equations, you can go ahead and ask any questions that you might have. You can write the questions on the chat box on the YouTube channel. We are live at this point of time on the YouTube channel. Or if you're joining through the Teams, then you can ask me direct questions also verbally through audio. Uh, we had opened the um, this thing, the interactive sessions for prior questions also. So the participants would ask some questions in advance. Okay, so we got one question from Dr. Thulluri Sudha, and she has asked, no, she has not asked anything. She has made a comment, which is, sir, please provide solutions for all assignments. Yeah, I have noted down this particular request. What happens usually in this course is that this course goes on for 12 weeks, and in each week we give out some assignments, right? A set of questions essentially, and the students are supposed to answer them, right, or in an online format. The questions that I generally ask in this course are essentially multiple choice questions. So you have 4 options and you have to choose one of them, the correct answer. Now that has been the pattern of assignments. So in all, there are 12 assignments in 12 weeks if the course completely gets over. And there is a one assignment at the beginning itself, which we call the 0 assignment. So in all, there are 13 assignments. So as per the request of this particular individual, Dr. Sudha, we are looking into the assignment. Some of the assignments solutions, I think, have been made, have been shared with the candidates. Uh, so I have instructed my TAs, that is teaching assistants, to share the assignment solutions, but I don't think all of them have been shared so far. Okay, it's because earlier we did not find any request to share the solutions. So we are in the process of sharing all the solutions, and they will be made available to the participants as soon as possible. So the instructions has been given to my teaching assistants. They are looking into it. If you have anything else, any other queries or particular questions regarding this course, then please go ahead. Or you might come up with some suggestions also how to improve this course, since we are coming to the end of this course, and those participants who have gone through this course might have some suggestions for me to make this course more user friendly, more accessible, easier to understand maybe. Or it is possible that you want to include certain topics which we did not include in this course so far, right? So those kinds of suggestions or comments that you might have, please feel free to share them. As far as this particular course is concerned, so let me share the screen so that you can have a look at the structure of this course. I hope you can see the screen here on your you can see the PPT on your screen. So this is the structure of this course for those who maybe they have not credited this course, they were not part of this course, but maybe looking at this particular video out of curiosity. So these are the things that we cover. These are broadly the themes that we cover in this course. But obviously, all the details are not here. For example, we cover a huge portion of financial economics, topics of financial economics. For example, present discounted value, how to calculate the present discounted value, and what uses they have. For example, calculating the mortgage, right? Or the calculating the period of the mortgage, or for example, bonds, value, price of bonds, rate of interest. What does it, the price of bond have to do with the rate of interest? Um, Decision regarding investments, right? How to evaluate different investment projects, which one an investor should take up and which one he should not take up. Those kinds of decisions which belong to the area of financial economics, we cover some topics of that also, because many of these mathematical tools that we discuss here are sufficient to cover those, at least those basic topics of financial economics. So this was one example. But apart from that, you can just look at the list of the topics. It's quite extensive. Uh, there are some topics which are not covered in this course, because we have to remember that this course is part one of a two-course sort of sequence. Uh, the topics that we have not covered in this course and could be covered in the second part are like topics of constraint optimization. So in this particular course, we talked about optimization where there is no constraint. So it's not that the person who is optimizing has to be within certain constraint. But in economics, many a time, the optimizer has to abide by some constraint. This could be equality constraint, this could be inequality constraint. So those things, those mathematical techniques have not been taken up here, but they can be taken up at a later course. So this is one. There could be other topics also which we did not cover. Uh, for example, differential equations. We covered difference equations, but differential equations is also important when we take the time to be continuous, because in difference equations, the time is taken to be discrete. So in economics, that is quite logical to consider time to be, discrete periods, because when we talk about, say, a financial year, right? So one financial year to the second to the third, etc. These are discrete time periods. Or even within a financial year, there could be quarters, but even if quarters, these are discrete periods. So therefore, if time is considered to be discrete, how do we approach the problem of dynamic changes? So one variable is changing with respect to time, and it has some relationship with other variables. Those things are considered in difference equations, but if time is considered to be continuous, then we have to talk about differential equations that can be taken up at a more advanced level. Okay, so these are the things we have not covered. But as I mentioned, this course is just part one of a two-course series. So in the second part of this course, we will cover the second these other topics that I just mentioned to you. So since we have not received any queries online so far, so maybe we can call it a day. And if you still have some questions, those students who have enrolled in this program, in this course, if you have any questions, you can always post those questions in the discussion board. The TAs of this course have been keeping a close watch on the discussion board. So if you have any questions or queries still which are unanswered, then you can approach the discussion board. You can post your queries in the discussion board. So I think we'll stop here since we are not receiving any questions. Okay, thank you. Have a nice day.